Okay, I'm back and we're continuing to do our lab on rocks and minerals. So samples 1 through 10 in your box of rocks and minerals are going to be called the silicate minerals because they all contain silicon and oxygen in their composition. So for example, if you look at olivine, so olivine is going to be sample number 7. So it's going to be this one, sample number 7. And it is green, olive green, so olivine. If you look at its chemical formula, you see that it's got SiO4, silicon and oxygen. So that's what makes it a silicate. And then you notice it's also got magnesium and iron in it. That's what's making it a dark colored mineral. Now you don't need to know about the chemical composition of any of these minerals with the exception of calcite. So I think that that one's important. But other than that, don't worry about the formulas for any of these minerals. But I want you to look at the formulas for the minerals that are in the chart that is there in the lab. And you'll notice that every one of those minerals has silicon and oxygen in it. And so the silica tetrahedron, which is the silicon and the oxygen, the silicon's in the middle, and then it's got 4 oxygens around it, so that's called a silica tetrahedron. In olivine, you have single silica tetrahedrons by themselves that are then glued together with the magnesium and the iron. But there's another way of doing it. The silica tetrahedrons could actually be glued together directly to make a chain of silica tetrahedrons. So that's what pyroxene is. And so pyroxene is going to be sample number 6 in your box. So this one here. And then underneath it is, now you could have 2 chains of silica tetrahedrons that are glued together like this, and then that's going to be amphibole. So that's going to be sample number 5. Okay, then you'll notice that the silica tetrahedrons can also be glued together to make a sheet. And so that is going to be sample 4. So you got your 2 different kinds of mica. Biotite mica is the black one, so B for biotite, B for black. And then the clear looking one is going to be the muscovite. Okay, then you could also have these silica tetrahedrons, each silica tetrahedron being glued to another silica tetrahedron to make a 3-dimensional network. And then that is what your 2 feldspars are. So samples 2 and 3. And then also quartz, which is sample number 1. So all I want you to see is that the silica and the oxygen go together to make a silica tetrahedron, and then the silica tetrahedrons can be glued together in many different ways to make different kinds of minerals. Okay, so now let's go down to your samples 11 through 13. Minerals 11 through 13 are precipitated when an ocean evaporates. So we're talking about sample 11, calcite, sample number 12, halite, and then sample 13, gypsum. So those are formed when an ocean evaporates and it leaves behind those kinds of minerals. So the question is, if you found calcite on a planet, what does it tell you? At one time, that planet must have had a blank. So fill that in for me. Minerals 14 and 15. So now we're talking about kaolinite, which is a clay. So that's this one. And then hematite, which is right next to it. So you've got sample 14 is kaolinite, which is clay. We have a lot of this in Missouri, only it's not white, it's what color? It's red. And then this one over here, this is hematite. So when it's in its natural state, it's gray. But then when it oxidizes, when it mixes with oxygen, it turns red. It rusts. So the question here is, here in Missouri, you might notice the red clays in the soil. What do you think gives the clay the red color? What must be mixed in with the kaolinite? Okay, now let's look at minerals 16 through 20. So these are going to be called ores. So we've already looked at one of the ores. So that was galena. So that's where we get lead from. And the one next to it is called bauxite. And that's where we get aluminum from. And then we've already talked about bornite, which was the peacock ore. And that's where we get copper from. And then we've already talked about magnetite, and that's where we get iron from. And then you've got finally sample number 20. And so this is called apatite, and this is where we get phosphate from. Now, it says your instructor will select 2 minerals from your box that you will be tested on when you take your laboratory exam. You will need to know that it is a mineral, and you'll need to know the name of the mineral. So, the 2 that you're going to need to know are going to be quartz and calcite. So quartz was sample 11, calcite was sample 12. So put that in those 2 yellow boxes. You should be able to identify them if I put them on the table as being a mineral, and you should be able to tell me what their names are. So we're finished now with the minerals, and when we come back, we're going to look at rocks.